So this is a beginning of a video series on the idea behind linear function, and we're going to build it over the course of a couple of videos to help you to see what makes linear functions linear. And it all starts with the idea of proportionality. And when we talk about proportionality, there's three ways that one could be thinking to see evidence of proportionality. The first way, we call it the scale or the scale factor. And the idea behind that is this. If we were to look at, say, on the x-axis, or the x-coordinate here, if we were to look at, say, from x equals 2 to x equals 4, we could say that 2 times 2 brings you to 4. Or we could say that 4 times something brings you to 10. Actually, it's 4 times 2.5 brings you to 10. So the scale factor is the times 2. What are we multiplying by that x value to get to this x value? What are we multiplying this x value to get to this x value, etc.? That's the scale factor. For two quantities to be in proportion, that is, this quantity x to be in proportion with quantity y, would mean that we would see the same scale factor between consecutive pairs of points. So for example, from 2, 3, when x is 2, y is 3, to 4, 4, we see a scale of 2. If this was a proportional relationship, we would have to see it times 2 over here as well. And 3 times 2, no, that doesn't work. These two quantities, x and y, that I've created here are not proportional. Same thing down here. In order to see proportionality, we'd have to see that 4 times something is 7, and the times something would have to be the 2.5 over here. And 4 times 2.5 we already know is 10, not 7, and so no. These two quantities are not in proportion. We can also see it looking at what we call the constant multiple, and that is to look this way, to look at the relationship between x and y. So 4 times something would be 0. Well, 4 times 0 would be 0. Let's jump down here. 4 times something would be 4. Well, 4 times 1 would be 4. We can do this one. 2 times something would be 3. 2 times 1.5, 1.5 would be 3. Notice we are not seeing a constant multiplier in between the x and the y, the corresponding x and y's. So this is not a proportional relationship. And then we can also look at ratios. Like if we look at the ratio from y to x, 0 to -4, 3 to 2, 4 to 4, 7 to 10. If we were to see a proportional relationship, all those ratios would be the same. And I hope you clearly see that they are not. So these two quantities, x and y, are not proportional, we would say. So why am I telling you all of this then? If this is not proportional, what's the point? Well, because we want you to think about proportionality and recognize when things are in proportion and when they're not. And what we're going to look at here is not quantity x, quantity y to see if they're in proportion. What we want to look at instead is what we call the change in x and the change in y. Now change is, or that triangle is the Greek letter delta, which means change in math and science. And by change, we just mean how much more is the one value than the one before it. So for instance, let's do the easy one first. 2 to 4. What we would say is there's a change there of 2 plus 2 is 4. So plus 2. From 4 to 10, there's a change of plus 6. 4 plus 6 is 10. By how much does x change by? By how much more or less is it? From -4 to 2. Let's do it. Think of a number line. From -4 to 0 would be 4 units, and then 2 more would be 6. So -4 to 2 is 6, 2 to 4 is 2, 4 to 10 is, again, 6. How does y change? 0 to 3, that's an increase of 3. 3 to 4, that's an increase of 1. 4 to 7, that's an increase of 3. So in blue, you see not the raw data x and y. What we see is the change in x and the change in y. And what we want to explore now is there a proportional relationship, not between x and y? We already know that that's not the case. We want to look at the relationship between the change in x and the change in y. So 6 times something, does that get you to 3? Let's look at that constant multiplier way of seeing it. So 6 times, well yeah, half of 6 is 3. So 6 times a half is 3. How about this one? 2 times something is 1. Well yeah, half of 2 is 1. Huh. So far we're seeing a constant multiplier. Let's try this one. 6 times something is going to get you to the positive 3. Yeah, 6 times a half. Half of 6 is 3. So yes, we see a constant multiplier, not between x and y, but between the change in x and the change in y. So what we would say is the change in x and the change in y are in proportion. And what we can also claim is this. For any change in x, you multiply it by that 1/2, and you're going to get the corresponding change in y. And that's a pattern I want you to see, is the relationship between delta x and delta y. And this relationship is going to be very useful to us. Now we could look at the scale, we could look at the ratios, and we would similarly see proportionality here, but I'm just going to pause there. So proportionality, change, and then now here it is. This 1/2, this constant multiplier from the change in x to the change in y, you multiply by a half. Multiply by a half. Multiply by a half. This 1/2 has a name. It's the constant, because it's a half, a half, half. Always it's a half, so it's a constant rate of change. Notice it's the proportionality between the changes in x and y, not between x and y themselves. So it's the constant rate of change. So we call that the CROC. Now when you have a relationship between two quantities, in this case quantity x and quantity y, such that their changes are in proportion, we say that that original quantity x and y is a linear relationship. Now what does that mean? Let's just take a quick look. X is -4, y is 0. That would be the point right there. X is 2, y is 3. That would be right about there. X is 4, y is 4. That would be right there. And then 10, 7 would be right about there. When you have a situation like this, where x and y are not in proportion, but their changes are in proportion, and that there's a constant rate of change, in this case of 1/2, a CROC of 1/2, then we know that that data, x and y, is going to fall in a linear path. What we mean by that is, notice that those dots fall on a line. And what's interesting about that line, okay, interesting to me, what's interesting about that line is this. We can see the changes when we look at this graph. Look. Remember that change of +6 over here? That was the change from -4 to 2. So x changes. This is the x-axis. X changes from -4 to 2. That's an increase of 6. So that 6 that we see here is literally the length of that little red segment right there. And when x changes by 6, the corresponding y, the change in y, is 3, from 0 to 3. Remember, we went from 0 to 3. And so here we see the 6, here we see the 3. And we can do that throughout from point to point. We can see this 2 and 1. So if you change from x equals 2 to x equals 4, that's clearly a change of 2. And when we change x by 2, y changed by 1 from 3 to 4. And we can see this last change from 4 to 10. When x changed from 4 to 10, that's an increase of 6. And when x increased by 6, y increased by 3, we see it right here. And so we can literally see those changes within, and if one wanted to, we could get it down to just a per one. And here's kind of what's interesting about this, at least to me again, is, remember this 6? So if we went 1, 2, 3, 4, 5, 6. If I take that 6 and cut it up into 6 equal parts. Then I would say go over 1 and go up, 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 over 1 and go up. And you still get there. You would still get there. But how much do you go up every time? You go up ultimately to 3, so you have to go up in steps of a half. So 1, a half, another 1, another half, that'd be 1 whole, another 1, another half, that'd be 1 and a half, 2, and finally 3. So every time I move over 1 in the change in x, I'd have to go up a half in the change in y. Another half would be 1, 1 and a half, 2, finally the 3. And we can see that here as well. Remember, this was a change in 2, so let's just break it into 2 pieces. Let's go 1 and 1. So if you go over 1, go up, over 1, and go up. Now ultimately, you got to go up 1. So that would mean 1, a half, another 1, a whole. There's your 1. What I'm trying to get you to see is every time you go over 1, you go up a half, 1, a half, 1 half. That's that same 1 half, that constant rate of change, that CROC. So I'm going to pause there because we are going to get to these other things on the list, but we'll do that in another video so you have some time to let this soak in. Enjoy.